Okay, we're good to go now. All right, so we are doing chapter 3. So chapter 3 is really important because we're going to be learning about our measures of central tendency. So some that you've already heard of, mean, median, and mode. Okay, then we have standard deviation and variance. Those are going to be new measures. And we're going to be using them for the rest of the semester. So those are very important measures of central tendency. Let's get started. All right, so we have mean. We already hopefully know what mean is. Mean is your average. Not sure what I just did there. Hold on a second. There we go. Okay, so mean is our average. Okay, it is going to be, the mean is going to be your most commonly used measure of central tendency. Okay, the formula for the mean, you have two different formulas here. Okay, so you have a sample mean and a population mean. So let's just go over again real quickly the difference between a sample and a population. Okay, so remember when I'm looking at all of something, okay, that's your population. Okay, and then if I'm taking a subset out of that population, that's going to be my sample. Okay, so if we're asked to find the mean or any measure here, we want to ask ourselves, are we using a sample or are we using a population? So you'll look at the context of the question. So a sample mean, here's the symbolism for it. So it is an X with a line over it, and we're going to call that X bar. Okay, and it goes like this. You have the sum of your X values divided by a lowercase n. Okay, so this means the sum of values and the lowercase n, that's going to be your sample size. Okay, so you guys already know how to calculate a mean. It's the same that we have already learned in previous math courses. It's just putting a formula to it. Okay, you add up all of the values, divide by how many. Population has a different symbolism. So this is the symbol for population. Okay, it's kind of like a U, but with a long tail in the front. This is the Greek lowercase m, which we pronounce mu, mu. Okay, so in general, when we're looking at all of the formulas throughout statistics, we're using, when we're referring to a population, we're going to use Greek letters in symbolism. And then when we look at a sample, we're typically using English letters in symbolism. And then the population mean, the formula is actually almost the same. So you have the sum of your X values, but this time you're dividing by an uppercase N. Okay, so it's the sum of the values. And then we're divided by the population size. Okay, then we have mode and median. So mode is the most frequently occurring element in a data set. And then the median, you remember what the median is? Middle, yeah, the middle number. So it's the middle term in a ranked data set is going to be your definition there. So we put the numbers in order, take the one in the middle. If there's an even number, what do we do with the two numbers in the middle? Yes, average them. Okay, so examples here. The only measure that we use for qualitative data, so there's no numerical data there, which one would be the only thing we could do? The mode, yeah. Okay, so if we're doing like eye color, you have brown, 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 green, green, blue. Only thing you could do there is mode would be brown, most frequently occurring. You can't find a middle or an average there. I mean, you could count how many, but that would be a different type of measurement rather than qualitative. What's greatly affected by outliers? Actually, what is an outlier? Yeah, it's really big. There's actually a formula for it, which we'll get to, I think in 3.3, 3.4. But yeah, it's like way out there. So one thing you tend to see that in sometimes, I mean, grades is a good example. Like if I were to take the average of all of the test scores, but let's say one person doesn't show up, they get a 0. That's going to really make the average come down a lot. Or a lot of people do really bad and then one person gets 100. So that's one thing that could be an outlier. You see it in real estate sometimes. Like you have like a bunch of normal size houses and at the end of the street there's like a huge mansion. Okay, so stuff like that. That's an outlier. And there is a way to actually determine numerically if something is an outlier. We will get to, but what is greatly affected by that would then be the average. So if I give you guys a test and I say the median score was this, that would be a better measure because that means it's not going to be affected by outliers. Okay, so the person that didn't show up, okay, that doesn't really affect it as much as the mean would. Where must we rank the data? Median, yeah. And then a measure of central tendency, that's going to be all of the above. All right, and then 3.2, I'm going to give you the formulas, and then we're going to do some problems. So the range is going to be the difference between the largest and the smallest variable in a data set. So you're just going to subtract the largest number from the smallest number. Okay, and then variance. Variance is a measure of the spread of data. And the symbol for a sample, remember we're using English letters, so it's just going to be S squared. And then for a population, we're using Greek letters. So this is going to be sigma, but lowercase sigma. So this is what lowercase sigma looks like, squared. Okay, and then our formulas. So the formulas are on page 92 of your textbook. You want that as a reference. And here we go. So for sample for variance, you have s squared is going to equal, it's going to be the sum of x squared minus the sum of x in parentheses squared over n, and then all of that over n minus 1. And then for a population, it's similar, but it's not going to be the same. So this one is where we do have to determine what type of data we're looking at. So you have sigma squared, and then you're going to have the sum of x squared minus the sum of x squared. This time this is over capital N. And then the whole thing is over just capital N, not n minus 1. Okay, and these formulas will be given to you on the formula sheet on the test. And your calculator does them as well. But we're going to do them by hand first. Okay, let's do standard deviation, and then we will do some problems. So standard deviation is going to be one of the most important calculations that we do in statistics. Standard deviation is going to tell you, here's the technical definition for it. So it's going to be a measure of how close the data is to the mean. One thing that I like to say for standard deviation is it's like that give or take, right? So let's say you were to Google how many M&Ms are in a bag of M&Ms. Okay, well, it's not someone counting how many they're putting in every single time they put in the bag. It's a machine putting the M&Ms into the bag. So sometimes it's going to be a little bit off. So you're going to see something like, I think it's 30 or 32 M&Ms in the bag with a standard deviation of 2 or 3 M&Ms. We'll say it's 2. Okay, so that means, well, the average bag of M&Ms has 30, but it's give or take 2. So it's between 28 and 32. Okay, that's going to be what's going to tell us how many M&Ms on average are in the bag, because it's not going to be the exact mean every single time. So that's your standard deviation, is you have your measure in the middle, but there's a little bit of a spread to it. So you're giving a window of opportunity to fall in that average. Okay, and then that window can get bigger and bigger to encompass the entire average or the entire data set. Okay, and we're going to do that with some examples as we get further on with like IQ. That's one that's really, really common, like height, things like that. Okay, that we'll look at. So that's standard deviation. The standard deviation for a sample is just a lowercase s. So it's just this, okay, but without the square. So you would just take the square root. So the formula is just s squared, so you find the variance, and then you take the square root. And then for a population, it's just sigma. So we'll say standard deviation is the square root of the variance. And as we go through, you might see me just abbreviate it into SD for standard deviation. Okay, so what I'm going to do now is I'm going to pass out some papers because I added some practice problems in that somehow did not get copied into the packet. So let me get those handed out to you guys. So in the first problem here, we are going to find the mean, median, and mode number of car thefts that occurred by a city during the past 12 days. Okay, so let's start with, we'll start with the mean. So the formula will act the same, okay, but we should still identify, is this a sample or is this a population? So if we're ever confused, let's ask ourselves this question. Is this all of the data for the city? Okay, no, it's just during 12 days. Now, if it were like 30 days, or you could say the month, then you could maybe argue like it's all of the month, but no, it's just a sample of 12 days. So this is a sample. Okay, which means we're going to be using this formula here. X bar is going to be the sum of X over lowercase n. Now, if this were a population, you'd still get the same mean, okay, but it will matter once we go into your standard deviation and variance formula, so you always want to identify that first. So let's see here, we want to add all of these together. So the sum of our X values. So let's see. Okay, and you could do this making a list in your calculator as well if you wanted. Let's see, 99 is our sum. Did you guys get that for your sum? And how many data points do we have? 12. So 99 divided by 12, 8.25. Okay, so our mean is going to be 8.25. Our median, we do want to rank the data, so we want to put it in order here. So let's see, our smallest number is 2. Then we have a 3 and a 4. Let's see, looks like we go to 8. And then we've got 9, 2 10s, nope, 2 9s. And then a 13 and a 15. Okay, so let's see. The middle number, there's 12 data points. So there's an even number. So let's find the two middle numbers. 6, okay, and 1, 2, 3, 4, 5, 6. Okay, so my two middle numbers are going to be 8 and 9. And then we'll find the average of those. So 8 plus 9 divided by 2, 8.5. Okay, so that's going to be our median. And then which one is going to be the most frequently occurring? 8. Good. All right, now let's take a look. Does anybody still need this? Good. Okay. All right, so we always want to read the data first. I'm going to have to zoom out, I think, to see all of the numbers at once. Not good. Yeah. Okay, so we have the following data represent the 2011 guaranteed salaries and this is in thousands, so you would add 3 zeros after each of these, of the head coaches of the final 8 teams in the 2011 NCAA Men's Basketball Championship. The data represent the 2011 salaries of basketball coaches of the following universities, entered in that order. So you have Arizona, Butler, Connecticut, Florida, Kansas, Kentucky, North Carolina, and Virginia Commonwealth. Okay, we want to find the range, the variance, and the standard deviation. So the range, first thing we can do, what's the smallest salary on here? 418. And what's the largest one? 3,800, which is 3.8 million. Just for reference there. And they're cutting other sports currently with like $500,000 budgets. Okay, so 3382, that's going to be your range. All right, so that's the first part. We've got our range. Now we want to do the standard deviation and the variance. So we have to ask ourselves, is this a sample or is it a population? So sample, do we agree? Yes, this is a sample because it is guaranteed salaries. It's just of 8 teams, okay? It's not all 8 teams. If that word were in there, that might clue us to a population, but it doesn't say it, so we're doing a sample. Okay, which means we're using this formula here. I'm going to go ahead and write it out. So you've got the sum of x squared minus the sum of x squared over n, all over n minus 1. Okay, so in order to do that, we do need to fill out this table. So we need to do 1,950 squared that's going to be 3,802,500. I'm just going to do these ones by hand here, so I'm not pulling up the calculator every time. All right, 434 squared, I'm getting 188,356. 2,300 squared, I have 529 and then 4 zeros. $3,575, I have 1,278, 0,625. 3,376, 1,139, 7,376. Let's see, 3,800, 1,444 and 4 zeros. Yeah. And then 1,655 is 2,739, 025. So I'm just going on the calculator for 18. My squared button is right here, up and to the left of 7. So then 174,724. Okay, now notice that I made a chart for this data because look at what I need. I need the sum of the x squareds, I need the sum of x, and then I square them. Okay, so if you make a chart, it helps to line up what you need. So let's go ahead and find those values. Just scroll down a little bit so I can use some space. So let's get the sum of x, and let's also do the sum of x squared. Okay, so first I'm going to add the x column. So the first column here, so 1950 plus 434 Okay, and let's make sure we put it all in right. So if someone could double check, 17,508. Yes? Good. Okay, and then the sum of x squared, I'm going to calculate my x squared column. So 3802, 500, 188, 356, 529, 1, 2, 3, 4 zeros, 1278, 0625, 1139, 7376, 1444, 1, 2, 3, 4 zeros, 2739, 025. And then 174, 724. Okay, so I get 50812, 606. You guys get that? Yes? Okay. All right, so notice it is very tricky with these. With the numbers, you could possibly hit the wrong numbering. You always want to double check that. That's why we do it in our calculator too, but I want to show you how to do it this way first. All right, so let's go to plugging these numbers in. So we have the sum of x squared. That's going to be this number here. So it's going to go up here. So 50,812,606 minus, it's going to be the sum of x, so that's that 17,508 squared over n, what's my n? 8, yeah, 8 teams. Remember, it's the final 8. So your n is 8. And then that's going to be over n minus 1. So 8 minus 1. So we have the formula plugged in. Now you want to do order of operations. Okay, so when I'm looking at the top here, I can put this whole thing in parentheses. Inside the grouping, okay, you've got an exponent. You have 17,508. You want to square that. Okay, then what comes after that? Multiply or divide. So we can divide by 8. Then we're subtracting. So then you do the 50,812,606 minus. Now, if I want to do this in my calculator and minus it, I don't have to type everything out. You can use this here. See above the negative sign, there's a yellow ANS. That means pull the previous answer and let me use that. So if you go second negative, it will subtract the previous answer. And then we're going to divide by 8 minus 1, which is 7. And that gives me my variance. Okay, so, and you can write it down as you go if you want to do each calculation, but you would do the exponent up here, then you would divide by 8, then you do this number here minus what you get here, then divide. Okay, so we get 1 million, that's your S squared, 1,785,192.57. I'm going to do 2 decimal places because we're talking about salaries, so it's money. And then for the standard deviation, all you have to do there is take the square root of that. Okay, so if I come here to my calculator, square root is going to be the opposite of my squared sign. Lost my mouse, hold on. There it is. Okay, so if I go second squared, it'll pull that yellow square root. And I want this second negative to pull the answer. And there's my standard deviation. So 1,336, and we'll do 2 decimals, so 0.11. Okay, that's a very large standard deviation. Okay, but as you can see, the range is very large in our data set here. Generally, the more data you have, the more accurate these numbers will be. You want to have a larger population. Now, let's put this in our calculators. All right, so we want to use a list for this calculator. So remember, list is up here. So go to stat, and then enter, edit. So stat, edit, and then enter the X values in L1. So after each one, you just hit enter. So if you already have something in there, see where my mouse is, scroll up to where L1 is highlighted, hit clear, and then enter. And it'll clear the list for you. Don't hit delete, because it'll delete L1 entirely. Then you have to reset your calculator. Okay, but hit clear. Okay, so 1950, 434, 2300, 3575, 3376, 3800, 1655, 418. I'm thinking I might become a basketball coach. All right, so we've got everything in the list. That's all we need to do. All right, so what we're going to do is we're going to go back to the home screen. So second, quit, takes you back to the home screen. Let me make sure I can remember this. So we're going to go stat, calc. Just here, because you only have one data set, one variable statistics. So just the first one. So stat, then over to calc, enter, and you want L1. So second one, which will give you L1. Or you can just pull second list, enter. And we've got lots of data. So we've got our X bar. We've got the sum of X squared. Okay, now here, see this? You have Sx, that's standard deviation. That's also sigma x, standard deviation. So the difference here is the calculator does not know if this is a sample or a population. So that's why you have to ask yourself, is this a sample or a population? Then you're pulling, because remember the formulas are a little bit different. In the population one, you're dividing by n. In sample, you're dividing by n minus 1. So those are going to be different. So we're going to pull the sample. Remember, that is your American letters, your English letters, S. Okay, Greek letters, population. Do you guys want to see where I got that again? Yeah. So we have the data in the list. Okay, then you're going to go to stat, then over to calc. So highlight calc, just go right. And it's right here, one variable statistics, enter. And then you want L1. So you can pull it from second one, or you could go second list, enter. And then it'll pull it up for you. Yours looks a little different. That might be because you have a TI-84, right? So let's see. All right, there's back page. This one is longer. All right, the following data give the number of hours spent studying by all 18 students in a randomly selected class during the past week. We want the range, the variance, and the standard deviation. So I'm going to let you guys work on this one on your own for a minute, and then we'll go over it. But before I do that, is this a sample or population? Good, this is a population. So make sure you're using the correct formula. Okay, let's go ahead and take a look at this. So, well, let's start with the range. So what is my largest value here? 11. And smallest? So my range is going to be 11. Okay, so for these columns here, I'm just going to go ahead and fill in the x squareds. So 4, 25, 1, 0, 81, 100, 25, 36, 16, 4, 9, 64, and 21, 9, 1, 4, 36, 64. Okay, so the sum of my x column is going to be what? 86. Good. Okay, so add all these together, we're going to get 86. And then the sum of my x squared column, 600. Good. Okay, so we have our values. So let's go ahead and plug those into the formula. So we're going to get sum of x squared, so that's going to be 600, minus our sum of x, so that's 86, squared over n. What's my n? 18. All over 18. Okay, and we can break this one out. I can do it step by step here. So let's go 86 squared. That's going to give us 7,396. So now that's going to look like this. Okay, then the next thing I want to do is divide 7,396 by 18. So let's go ahead and 410.89 will do. And then 600 minus that. Can't find my mouse. Oh, there it is. So 600, and I'm going to keep this on my calculator, so I'm only rounding when I'm writing it down because I don't want to round until the very end. So I'm going to go 600 minus second answer, so I can pull that through without rounding. So that's 189.1 repeating. Over 18, and then in my calculator I will divide by 18, and that will give me 10. And now I'll round. Typically, unless it's money, we'll do 3 decimal places, and then if it's money, we'll do 2. So we'll do 3 decimal places here, so 0.506. So that's my variance. And then for my standard deviation, I'm just going to take the square root of that. So square root of second answer, and that will give me 3.241. All right, so did we get that? Good. So let's check it in our calculator just to go over that. So I'm going to put this in a list. So I'm going to go stat, edit. I got to clear this, so I'm just going to go up and then clear, enter. And then I'm going to type this in. So 2, 5, 1, 0, 9, 10, 5, 6, 4, 2, 3, 8, 11, 3, 1, 2, 6, 8. All right, and I know that I got them all because when I go down to the next one is the 19th, so it would stop at the 18th value. So if you ever just want to check that, just go, okay, like if that said 18, then I missed one. I want to go back through everything. All right, so then I'm going to go back to my home screen. So second quit, then stat, calc, enter, and then I want L1, so second one. All right, and then I want the population, so I'm going to pull sigma x 3.241. So see how close those are? You could potentially enter the wrong one in and get marked wrong. That's why you have to ask yourself first thing, population or sample. Okay, so then here, what could I do with that data? I could say, okay, well, according to a survey of the students in my class, students on average study 4.78 hours with a standard deviation of 3.24. Okay, and that is the data there. So then you could make requirements about studying. You could say, okay, so based on that, the average grade was blah, blah, blah at the end of the semester. So if you want to do better, you would study more, you know, kind of thing like that. So that's kind of where we're going to be going once we get to chapter 6 and beyond with the data predictions. But this is now just learning what the formulas are, how they're used, how to calculate them. And we're going to go pretty slow with this stuff just so you can get a good grasp of it before we move on. So that's going to be it for today. And then on Thursday, we'll do 3.3 and 3.4, which is we're going to be the same thing, but then we're going to look at group data. So it's going to be where we're looking at a range of data, like the one with the credit card sample, where it's how many did you have, and then you were in the range of like 2 to 4, you'd put a tally. So that's what we're going to be doing on Thursday.